Welcome back. If you recall, I in my previous classes I told you about the tension. I started with the laws of motion. I made a statement, a theoretical background. Then we looked at the three base forces, and finally we were looking at other than gravitational and strong force. They are your electromagnetic forces. These electromagnetic forces, as I have made a mention, we're going to essentially deal with four: the tension or the tensile force, or the normal force, frictional force, and the spring force. All right? So we started with tension. Tension, I want to just give a brief recap of tension. It is internal restoring force, and any unsuccessful attempt you make to stretch an inextensible wire, rope, or chain would manifest itself as tension. Tension acts both ways, number one. Number two, tension is in general pulling force for all flexible bodies, and tension could be pushing as well as pulling if it is a rigid rod. They are the simple things I have told you. And another point I spoke about this is, if that wire or the chain string is having a negligible mass or massless, then tension remains same everywhere. This is a point I made it to you, right? Then another point I tried to tell you, that this is true in all the cases except when it passes over a rough or a heavy pulley, in which case tensions will differ on both sides, although it is massless and it is the same rope. But if you take a heavy rope, tension differs from point to point. And I think I took an example of a force another. I gave you about two special cases. And when does tension arise also? I gave you a number of examples with a slacken, straighten, and pulling, etc., etc. Now I continue with the heavy rope case. If you recall, this is something that I kept it to you. If the linear density is constant, where in advance they can go when you take a heavy rope. I think on this, if you take F1 here, and then this is a distance x, and first we took lambda constant, then this is lambda is equal to kx. You may take any such thing likewise. Now I'm going to, this is 1, this is 2, I go with lambda is equal to, say, k sine some function I'm giving, right? K sine pi x by 2l. What does it mean? Just look at that. If x is equal to 0, then lambda is 0 here. If x is equal to L, k sine lambda becomes k. In other words, it's a case of a variable density. Definitely variable mass, but even variable density also. So every strip, if you take, the density goes on increasing in this case. Okay? Now, if you take like this, our procedure remains the same. I'm going to give you one more example in the same vein, but I want you to be able to do these things on your own at every stage. That's the reason why I'm spending a little more time on this. Now, as we did before, we take a small strip. This is T. Every time you take a technique of integration, you are supposed to take T and T plus dt like this in the increasing direction of x. Therefore, and you know that the whole thing is accelerating. I am presuming it is accelerating like this, in which case T minus of T plus dt, which is minus dt, the mass of it is dm, a dm. But dm is lambda dx. Why? Lambda we defined as linear density dm by dx. So I'm using it here, okay? So minus dt is equal to A. What is lambda? A sine pi x by 2l dx. Now you could see on left hand side you have only one term, right hand side all in terms of x. Therefore you can directly integrate this. But I told you, I'm repeating it, every time you perform such kind of integrations, first perform with extreme limits, then perform with one unknown limit so that you will get the value at the point of your interest. So for example, dt, this becomes t, is a negative sign, ak, what is sin x dx? Minus cos pi x by 2l divided by the constant is pi by 2l. In the case of integration, the constant is to be divided. In the case of differentiation, the constant is to be multiplied. But don't go beyond a constant here. Now the limits. What are the limits that we would like to take? At x is equal to 0, tension is F1. At any x, tension is Tx. Now substitute negative sign if you remove, or both the negative signs get cancelled. You have a negative sign on this side, negative sign that gets cancelled. Therefore, you can now, I'll erase this part and right there. So what do you get here? Tx minus F1 is equal to 2Lak by pi, cos that remains as it is, minus cos 0 is 1. The same thing I will go with extreme limits now. 0 to L, F1 to F2. So, I'll get F2 minus F1 2Lak by pi. What will happen to this? When it becomes L, LL gets cancelled. Cos 90 is 0. And 0, this value remains the same. Got it now? Now, I divide these so that this entire constant goes off. So that minus 1 you can take it here. And this will be F2 minus F1 into cos pi x by 2L minus 1. Right? Now this Tx, you take it on to the other side, everything will be, so that minus of minus it becomes plus F1 into 1. And now this minus, if it comes onto this side, plus F1. So plus cos pi x by 2L minus 1. Right? Now that is equal to, and then F2 also you have to bring on to this side. F1 I brought, F2 will be minus F2 into cos, all this is equal to minus Tx will go on to the other side as plus. When I rewrite this, Tx is equal to, now this one gets cancelled, F1 cos pi x by 2L. This minus I will reverse this here, plus F2 into 1 minus. Now look at this. This is important. If you put x is equal to 0, you should get F1. If you put x is equal to L, you should get Tx is equal to F2. See, I am purposely giving you these cases for you here. Please try to understand why am I doing it. When a rope is given, how to do it, whether a lambda constant, whether lambda is simple function of kx, or let it be kx square, you continue to do the same thing. Ky square, continue to do the same thing. In a similar way, if I give a typical function, which probably you have not heard of before, then this is how you are going to get it. So, what is the tension? I am writing it here. F1 cos pi x by 2l plus F2 into, that is the expression you get. You see, I have given you lambda constant, lambda proportional to x, lambda proportional to some sine or cosine function. Now if I go, lambda is equal to, suppose if I take k e raised to x by l, k e raised to x by l. What does it mean? At x is equal to 0, lambda is k. At x is equal to l, lambda becomes ke. It is same as before. Lambda is equal to kx by l, right? Now, same as before. No difference whatsoever. So, I can directly write minus dt is equal to a lambda dx. Lambda you substitute a k e raised to x by l dx. Now it is straightforward, therefore you can integrate it. If I integrate, you will get minus t. I told you at x is equal to 0, it is f1, it is tx, and all this will be ka e raised to x by l integral will be 1 by l. That is l, and limits are 0 to x. How do you get? Tx minus f1 with a negative sign, kla. Now, what do you get? E raised to x by l. E raised to 0 is 1. So, if I substitute the extreme limits, by now you must be familiar with all this. Minus of f2 minus f1 is equal to kla. Now 0 to l. L means E. Got it? Now just divide minus minus. So you have dx minus f1 into E minus 1 is equal to f2 minus f1 into, this is how you got it. Now you have to rearrange these terms to write an appropriate expression. So I retain tx here. Now if I take f1 onto the other side, minus f1 becomes plus f1, e minus 1, and then f1 is minus of minus 1 and minus e raised to x by l. So 1 gets cancelled, okay, and plus f2 into, so what are you getting? f1 into e minus plus f2 into e raised to x by l. Got it now? This is how you will get your tension here. Okay? Now, I will write it down here. So that Tx is equal to F1 into E minus E raised to x by L plus F2 into E raised to minus 1. Any number of examples can be taken. Now you can try on your own, and if at all you find a mistake in any one of these things, I will be very happy. And I'm glad that I have come to the mistake so that I am giving you a chance to correct it. Please understand this. And you can put it in your comments, I would welcome. This is as far as variable tension in variable rope is concerned. Okay? Now, I will keep the variable rope apart. I continue to discuss tension. Now, in this tension, you have to be careful. I have just given you only a straight wire, etc. Now, if I go to a pulley, now light and smooth pulley. Very important pulleys for you. Actually, you don't have multiple pulleys in your system, but we do discuss multiple pulleys also. Light and smooth to avoid all complication. Light means less mass. Smooth means no roughness, no frictions or no complications. I just take a pulley like this. It is fixed. And a rope is presuming that they are different, having different masses. You know that if its mass is more, it will move down like this, it will move up like this. And all depends on your forces. So it would accelerate down, it would accelerate, that is intuition. Intuitively, you are aware, I am aware, that if this accelerates down, this will accelerate up. So this is one very important thing. Dynamics is one part of the story. Now let me first of all look at the dynamics here. I know nothing about any of the information. How do I draw, presuming I am not aware of any of these things? I think that this is one rope, this is another rope. By thinking like that, what do? I just show you. I draw FBD. I told you FBD is a free body diagram, and the wire here has a tension T1. I do not know. And I am presuming it is going with the acceleration, even down or up or whatever. I took just like that down. If I take it down, how do I write the equation there? Downward forces minus upward forces is equal to mass into acceleration. Where did you get this from? Newton's second law. In a similar way, now it looks bizarre when you are writing all this. Remember, many a time we try to use all our intuition into the concept and forget about the fundamentals there. So I am attacking the fundamentals here. I want you to be very careful and know once for all how you got this. That is very, very crucial for you. So I am taking the most appropriate, this is not M to G, this is T2, and I don't know. I know one thing that is inextensible. means total length of the wire cannot change. So how do I write the equation first of all? If I get like this, minus T2 is equal to M2 A2. Right? Got it. Two equations, two bodies, but there is another body here pulling. Although fixed, we will draw FBD for that also. How do you draw FBD for the pulley? This is the pulley. Now, some force, clamp force, is pulling it up. This is T2. This is T. Okay. Now, there is another concept that is involved here. Whenever a force is applied and you have fixed this at the center, there is a tendency for this wheel to rotate, for the pulley to rotate. So the force at what distance you are applying, if you take and multiply this distance with this magnitude of the force, you get what is known as moment of force. Just as you have got some other forces equal to mass into acceleration, you also have some of the moments is equal to another parameter called related to mass into angular acceleration. But we said its mass is 0. Therefore, what do you get from this? T1 minus T2 is equal to 0 into alpha, because if I take this as R into T1 will pull like this, R into T2 will pull like this. Both moments are acting opposite, so I put like this, and I said this is 0. Whatever mass related parameter, actually you get moment of inertia here, but it's not right time to discuss that. Therefore, I will write here T1 is equal to T2 is equal to T. So what is it we have understood? And why are we doing all that? I am now trying to develop equations based on the dynamics. I have used all and I got it now, end of it. What do I do with all this? For me, M1 is known, M2 is known. I do not know what is the tension. I have to find out tension. I do not know what is A1. I do not know what is A2. I have to get. So, if I substitute all this here, this becomes a set of two equations. Got the point? Set of two equations. How many variables are there? T, A1, A2. How many variables? 3. How many equations? 2. So, it doesn't form a closed set. What do you mean by a closed set? The number of parameters must be equal to the number of equations. Then only it is possible to solve. I'll give you an example. 2x plus 3y is equal to 5. I ask you to solve it. Can you do that? You can never. Why? Because there are two variables, one equation. If I give you another equation, x minus y is equal to 4, then you can solve two simultaneous equations. The whole of Newton's laws of motion, rotatory motion, wherever you keep these equations, your sole purpose is to solve the equations for unknowns. I am intending to find out what is A1, what is A2, what is T here in this case. And it's not possible for me to do it. I have exhausted dynamics. What do you mean by exhausting dynamics? I have made use of Newton's second law, got one for this, got one for this, got one for this, done. At the most you have one more thing here is F, this is an equilibrium. Meaning, see, this is balanced by this. But that equation is not going to be of any use to me, because what is the clamp force if I ask? or what is the thrust on the pulley, then you are actually putting a rope over that and pulling from both ends. So what is the thrust acting on the pulley is the net force, and that is nothing but in this case it is equal to 2T. Be careful, I will give you a few examples of thrust on the pulley, how to work it out. But primarily my intention now is to take you into something, a very new concept for most of you, if not all. And then it is very, very interesting to solve those cases one after another. So I have exhausted dynamics, but I have to solve this problem. That means what? Probably there is an interconnectivity. I have taken A1 as acceleration of M1. I have taken A2 as acceleration of M2. That means A1, A2, are they dependent or are they independent? Now, as of now, I took them to be independent because I do not know. But if there is any interdependency, which you have to find out, this is not free to move without having any connection with the M2. We know that. Vice versa. I took them independently, and if I can establish what is the dependency, which has nothing to do with the forces, therefore it is a pure kinematic relation of the movements. Movements means displacements, velocities, accelerations. That's it. I don't go to the force. The force part is consumed. It is done. I'm done with that. I just have a problem of understanding A1, A2. You may now ask me, sir, why did you take A1, A2 separately? Because as I said, I don't know. Two bodies may move with the two different accelerations, and if not, I'll try to establish that they are not, and then I'll try to give you what is the relationship between these two. That's what I'm trying to do here. So, A1, A2, are they dependent or are they indifferent? How do you know this? Presuming that this is an extensible wire, then they are independent because it will act in its own way, this will act in its own way. Elastic forces will come into play. But what did I say? Light pulley, smooth pulley, light rope, inextensible rope. These are the assumptions. See, whenever I say light rope, every rope will have a mass. But if I am attaching masses which are tens and hundreds of kilos, this half kilo etc. is not going to matter to us at all. So be careful about that. I will come to that also, what will happen, everything. Okay. Now let us see. So M1 and M2, A1 and A2, and I took incidentally, because it is inextensible, one thing is the total length of the rope must be a constant. That is number one. You can do that by taking the total. Then I will try to establish a relation between the two displacements, the two velocities, the two accelerations. As I told you, because you are trying to get the relations among these three variables only, we call it as kinematics. So every problem in Newton's laws or from Newton's laws onwards, always look for kinematics in addition to dynamics. These interdependent relations are called constraints. And this pertains to rope or pulley. You may call them as rope constraints or pulley constraints. Constraint means what? This body is not free to move without having a dependency on M2. It is constrained to move in accordance with the movement of the other body. What is that relationship is what we are going to give in constraint relation. What is the fundamental basis to get this relation? Total length of the rope is constant. Now here I'll give you two types. One, how to do this one conventionally, just as I have explained to you. I'll do that one by one. What is the convention? From any standard point, say here or here, I'll say this is x1, x2. Okay? If I ask you what is the total length of the rope, how do you write? From here till here, x1, a part of it is here and another remaining is x2. So, x1 plus x2, but some part, I don't know what it is because that part will never change. So, we need not worry. If I take L is equal to x1 plus x2 like this, if I take their departures, delta L, change in length, delta x1 plus delta x2, k will not change. A small change here, delta L, but you know there is no change in the what? Length of the rope. Therefore, delta L is equal to 0. So what does that give you? S1 plus S2 is 0. Whenever I talk of from a fixed point and take the lengths of these ropes, etc., be careful. Whatever you get here, all will be in the same direction. If I am getting displacements, I have to imagine S1 downwards, S2 downwards, or S1 upwards, or S2 upwards, likewise. Okay? That you know if S1 is equal to minus S2, obviously one is opposite to the other. That is what we learn from constraint relation. Suppose if I divide this with the time, what do I get? V1 plus V2. If I further divide it, what do I get? A1 plus A2 is equal to 0. Or A1 is equal to minus A2. If A1 is upward, A2 is downward, both have same magnitude. This is something that we were trying to put in terms of intuition, which I have avoided. I want you to understand this closely because you are supposed to use this throughout mechanics, wherever you go. So this is a constraint relation. How did I get this? I got this with the conventional technique. From a fixed point, length of the rope you find out, change in length 0, you differentiate with the time, get velocity expression, further differentiate, you get acceleration expressions. You got them? Is this clear? If this is clear, I am going to give you a two-finger technique. Okay? Now this is very crucial, very important, very easy in some cases. So you can use it wherever it is feasible. For this, you have to first imagine that A1 downwards, A2 downwards. Now, whether I talk of displacement, in this case, whether I talk of velocity, whether I talk of acceleration, it makes no difference whatsoever. Okay? Now what do I do here? Now look. How many segments each rope has? You see, if one rope is there, you will get one constraint relation. If two ropes are there, you will get two constraint relations. Three ropes, three constraint relations. Any number of ropes, so many constraint relations you get. Now, each rope, first is only one rope in this problem, no issue. How many segments it has got? Segment 1, segment 2. Each segment How many edges? A, B. Now be careful, I'm not talking about the rope here, segment. This is the segment. I'm putting it here. Now look, this is the segment. What do I do here? I first of all imagine that this is fixed. So this one alone is moving. How is this moving? You see, when I'm fixing the upper one, lower one, how is it moving? Downwards. Down or up is not the criteria for you. Because of the movement of one of these edges, does the segment increase or does the segment decrease? Here I repeat, one segment, two edges. One edge I am fixing it. The second edge I am imagining. Now how did I take A1 downward? So it is increasing. Segment is increasing. Therefore, I will write plus S1 if it is S1. So plus S1. This is over. Now I fix this. I look at this. If it goes up, I will take, it is increasing. If it goes down, it is decreasing. Be careful. Here it is going down, still I got plus. Now here if it goes down, I am getting negative because segment is decreasing. That is why I said, very carefully follow my arguments here. Downward movement positive, upward movement negative is wrong. Because of the movement of these two parts, simultaneously I cannot do it. I fix one and look at the other, and whether the segment increases or decreases, based on that I will get plus or minus. Okay? So this first I repeat, first I fix this, going for this, so it is increasing. So I put pluses. Now I am fixing it. This is fixed anyway. It is not moving at all, this segment part. Because it is a fixed pulley. If that pulley is moving, well, down you will get negative in this case because segment decreases. Up means positive likewise. Okay? So there is no change in these two segments. So one segment, one gives this. What does segment 2 give you? Now you can, this is fixed. Now this is moving. What is happening? What is happening to this? Segment is increasing. So let me take it as S2. I fix this. Now this is also fixed. Therefore 0. Now there is a change here, change here, change here, change here. With algebraic, what should happen to the sum of all the algebraic changes for the total length to be constant? The total algebraic sum of the changes must be equal to 0. Therefore, what do I write here? S1 plus S2 is 0. Differentiating y1 plus y2 0. Further differentiating, you will get a1 plus a2 0. Okay? You got it now? So this is what we call as constraint relation. Okay? Now, both I took down, therefore I have written like this. Now how do I solve this set? First I will tell you. You said a1 plus a2 is equal to 0. Now 3 equations, 3 variables, you can solve it. Every time they ask what is constraint for this, don't give a1 plus a2 is equal to 0. Unless they say a1 like this, a2 like this. They have to say. You cannot do, don't take or accept it as a universal constraint relation. No, it is not. Each case it differs, same problem. I'll show you a little while from now. Now this is nothing but, so if I take a1 is equal to plus a, a2 is equal to minus a, then what do I do? I simply substitute it here. M1G minus T is M1J, M2G minus T is minus M2A. Now you can solve it. That doesn't take very much time for you. Divide the two equations, A gets cancelled. Solve for T, you will get, I'm not wasting my time to do all this unless a necessity comes. And A is equal to, and this is called, this arrangement, fixed pulley is called Atwood machine. This is called Atwood machine. Anyway, my purpose of this is when a light pulley passes over a light rope passes over a light and smooth pulley, when I apply the dynamics, I am getting a peculiar situation where I got a number of variables to be more than the number of equations. Therefore, I was forced to look for any interdependency of the movement of both these bodies, or are they independent as I initially took, or intuitively you can do it. Fine. So we solved it. We got the constraint relation. What technique I told you? The total length of the rope is constant because the rope is inextensible. From a fixed point, take the distances, write the length expression, differentiate, you will get the answer. And you got it, we solved this. This is fine. Now, the same problem is given like this. Now, my intuition tells me, A1 is like this, A2 is like this. They may ask what is the constraint relation here. First of all, we write the dynamic relation. Dynamic relation, how do you write? Take, this is as usual, weight of the body acting down, tension always away from the body. Now I need not have to take T1, T2 separately because this is a light and smooth pulley. Tensions are bound to be the same on both sides. And you said A1, so how do you get right? What about this? Remember, look, it is somebody's intuition. You can't question that. And he said it will go down, this will go up. Fine, doesn't matter. How do you write this equation? Down means M2G opposite. Right. Got it? He has given A1, A2 like this. I am now writing the dynamic relations. I got it. Now what about the kinematics? Why do you go for kinematics? As before, you got 1, 2, 3 variables and 2 equations, so there is no way. One, you take the total length, that also I will show you. Well, this is x1, this is x2, likewise. But the problem with x1, x2, the length is, you can't take in the directions of your choice. That's very important. Whereas, if I take my original technique that I gave you, what did I do? I will show you that. Now, I will come on this side. So, look. 2 segments, right? This is one segment, this is fixed. And now, what is happening here? This is moving up. So, displacement. Now, up or down is not the criteria I've been telling you. If it moves up because of the movement, what is happening to the segment length? The segment decreases. So, minus S1. And so I fix this, but you know that this is fixed. Therefore, 0. Come to this. I fix this. Now, look like segment is increasing. So, plus S2. And fix it, this is also fixed 0. So, what are you getting? Minus S1 plus S2 is 0. Mind, if you differentiate this, and if you differentiate further, you will get minus a1 plus a2 is equal to 0. So what is your relation here? Constraint. Look at what you have got in the previous case. a1 plus a2 is equal to 0. Remember, whenever he gives the directions, don't use the same length technique. Go by what I have tried to give you. Now you can solve it, your answer will be the same. So this is the beauty of this. You may do a1 down, a2 down, a2 up, a1 down, whichever way you take. But write your equations appropriately, get the constraint relation appropriately, and you are going to get your ultimate result as t is equal to 2m1 m2g by m1 plus m2, and a is equal to m1 minus m2 by m1 plus m2. Or m2, whichever is that. This is bound to be the same. Remember that. Is that clear to you? I have taken the simplest of all possible cases and tried to explain it to you. And you also try on your own, and any problem you put it in your comment section. I will address that. Now I will go deep into these things in my next lecture. Thank you.